Hey everybody, welcome to the Hack Together. And today we're going to be talking about generative AI for the .NET developer. My name is Matt Soucoup. I'm a cloud advocate for .NET. I love .NET. I love AI. I love talking about it. But today I am joined by a special guest. I'm excited. You all are in for a special treat when we get it down to it for the demo. Diego, tell us a little
Yep.
bit about yourself and everything, because off to you.
Well, thank you for having me here. Part of the .NET Interactive and Polyglot notebook. That's what I do for a living. But all this AI storm has been a lot of fun, and I've been spending quite a few months now all around all the stuff that we're doing around .NET and Azure for the AI, especially all the cool things when it comes to semantic kernel, Azure SDKs. So it's a lot of fun and early days in the journey. So I don't think there's really a way to get it wrong. It's so early days that as long as it
Yeah.
works, it might be
Yeah.
right.
And actually, that's a good point. It is super early days, and that's where the Polyglot notebooks, I think, come in super. We'll get to the Polyglot notebooks, but that's where I think they come in super duper helpful for us. Like you can take it down and you can nicely prototype out your applications as you go, because it gives you a nice way to go through and
Yeah,
see
and
what's
we'll
going on.
see that is real C sharp and
Mhm.
real .NET and real packages. So as you experiment and sketch around your ideas, whatever that works, copy paste. We
Yeah.
shouldn't do that, but copy paste into
That's,
into
I
your
don't know how
project.
else to code.
And it
I
works.
don't know. I mean, if I didn't copy paste, I'd
Copy
be,
paste is the old way, right? Copy
yep.
paste from Stack Overflow is gonna be changed into copy paste from Copilot chat,
Yes.
isn't it?
Yep.
That's the new copy paste.
Yep. Indeed. All right. So Diego, let's start first about talking about what the great .NET 8 hack is all about. So we've been doing a couple live streams overall. Last week we did, I believe, two. The first one was just the welcome to .NET 8 all up, and then Chris Noring did also an AI stream as well. And what the great .NET hack is, it's a part of a group overall effort. And so you can go to aka.ms/hacktogether/.net. It's going to bring you to a GitHub repo. And there you can go through and register for this hack. And you can build applications either with a cloud native or for AI. And Diego, get a load of this. Once you
Mm.
submit your application, you can win up to $500 for best AI app, best cloud native app, or best overall app. So that's $500 AI, $500 for cloud native, and $500 overall. Diego,
And
though, I got bad news.
if
I got
if
bad.
if you do the cloud native AI, do you win the whole three?
No, you know what? No, I got that question once before too. But you kind of get, if you have a great AI app, but it's not the best AI app, but it's the best cloud native app, you can kind of win there. So, but I got bad news for you, Diego. Full-time Microsoft employees are not eligible. You and I, we can't win. But that's bad news for us, but good news for everybody else. So yeah. So, anyways, follow that aka.ms link, get registered, ask questions. It's a full-on discussion group going on there and everything else. And get your entries in, because everything closes up on December 4th. That's next week. So you still have a week. We have a stream today on AI. Tomorrow, we're doing a stream on cloud native. We're going to be talking about Kubernetes. We're going to be talking about the
Wow.
brand new library called Aspire, which just got released with .NET 8. So amazing stuff going on. Learn about .NET 8. Super great. All righty. And even better, Diego, I don't know if you heard about this. Part of this overall hack together is that we have a proxy that gives everybody free access to Azure OpenAI. That's pretty amazing, because right now you have to go through a wait list. You have to have an enterprise account for Azure. It's There is bureaucratic access, stuff going on, but here we'll be able to give it to you. We're going to make you tune in for the entire episode, because I'm not going to show you how to do it till the end. That's for a cliffhanger. But yeah, we'll just ask for you to use it responsibly. But overall, super cool. All right. So first, though, Diego, what I want to do here is go through and give some fundamentals of the overall AI, generative AI landscape, because I find a lot of times when I get down to it, it always helps to know like the foundational pieces that go on. What essentially what terms are and how the terms play in with each other. So, very first thing, the models. And I always think, tell me if I'm wrong here. Diego, you're smarter than me. I think of the models as the brain of the artificial intelligence. They really, it does what it does. I mean, that's like, so you can have a Dolly model, and a
Yeah.
Dolly model is you get image from the text. And so DAL-E is the model, and it's the model that is responsible for producing the images based off the text that you put in. So is that fair to call it the brain at that point then?
Yeah, I would say so. I mean,
Okay.
that's you submit your question and they give you back the answer.
Yeah.
I'd say call it brain or the engine.
Yeah.
That's pretty good.
Yeah. Saying the brain might be anthropomorphizing, making it too human-like, but
Well,
yeah.
sometimes I find using pronouns for
Yeah.
AI anyway, so let's
Yeah.
call it brain. It's good.
Yep, I guess. And so there's a couple different models that are out there. There's the language models, which is the GPT models, the ones that we can chat with. There's GPT-4, GPT 3.5 that are out and available for Azure. Um, then there's embeddings, which are we'll talk about embeddings in just a minute, but embeddings are super cool because they take language and they make it into math, essentially.
I'd say so.
Yeah. Dolly that we just mentioned, and then Whisper. You don't hear too much about Whisper, and
People only whisper about it.
yeah, it's a secret. It's a total secret.
Exactly.
And what it does is it takes your speech and moves it over to text. And how, Diego, do you know how long Whisper's been around? Has it been around a while? I mean, is that why
It
is it
is.
newer or is it?
It's not incredibly new. It's been quite few months around OpenAI. There was a lot of experimentation going on, and some other providers had this model out. There's also version of that you can run if you got beef enough machine. There are stripped down version that you could run on your machine too. That's actually quite some interesting .NET packages, NuGet packages that you can get is the Whisper CPP, things like that, which is a way that
Oh,
runs that on your machine. And it's quite interesting compared to, the ChatGPT you mentioned about the one that you talked with. So it's really, ChatGPT is the only one that answer your question. The other ones, they more or less satisfies your request. So the Whisper one, for example, we can see a few things. So Whisper is quite interesting because he's got prompting too, but you're not really asking questions. You're just helping Whisper to be
right.
more accurate. So when you send things to him, there you go. Now the brain and pronounce with AI. When you send your prompt to that, usually what you're gonna try to do is that correct the spelling because I want products. Or if you're talking about specific things, you want that to be informed. So it's only using text to help generating a better transcript. That's it. You cannot ask a question to Whisper. Same as
Gotcha.
DALL-E, right? It's going to
Yeah.
give you an image out. So it's about you describing what's the image is all about, what's going on, the mood, styles, and things like that. So their prompting is more about describing how you want that model to do the job, as opposed of GPT, where it's trying to answer your question.
Gotcha.
That's even is a generative text model.
Right. Right. Yeah, that makes sense. Both the embeddings, the image, and the speech, the text they're an ending. Where the language models, you can kind of go back and forth, to your.
We're gonna see that because that's I think is a little bit of misconception out for the is GPT, but there is no chat in the name of the model. We're gonna see that later, right?
Excellent.
Because that's the trick is when you turn those models from a completion. I ask you something that gives you back the response. It completes your question, and the conversation part is a different beast. But it's the same model, so you can use those things to do a couple of different things, and blending them becomes interesting at that point. But it's the
Excellent.
same model. You just use it in a different way.
Cool. Another cliffhanger. All right.
I like that.
All right. So we let's go, kind of talk about the completions then. And a lot of completions then is well, completes, you feed the model in an input. And so the input kind of, it's the prompt. You're telling it, it's the I like to think of the prompt like you're programming the model essentially. You're like sending in, it's like almost you're writing an if statement or some kind of a while statement or a for statement, but in plain everyday language. And the model, at least for completions, is bringing back what it thinks statistically makes the most sense of what comes back. Now, I was really, when I made the slide, I was, um, I want to make, I did say statistically makes sense. I didn't want to say what it thought made sense, because you want to be careful.
There's a lot of
Um,
conversation about, does a model reason about the prompt, or is just trying to statistically
yeah,
make sense? A parrot versus reasoning kind of
yeah,
behavior, right? Because
yeah.
they get trained on so much stuff. Sometimes you get it up. It's just regurgitating one of the billions of trillions of billions samples the model has
Mhm.
seen through the training. Uh, does he understand my question? Is
Yeah,
is actually the model doing that?
yeah. Yeah. And so sometimes it does seem like it's super, sometimes it seems like it's thinking, but it's not. Unless there's
That's
something
good.
secret out there.
No, actually, what's interesting is that the old school definition of AI, right, artificial intelligence, and that's also the things about the test, like the Turing test, is that a system is intelligent if given a question, the answer being produced, so the behavior that the system has is a behavior that you would associate with the behavior that an intelligence would do. So
Mhm.
really, AI is in the eye of the beholder.
Yeah, we're veering into philosophy now, but
I
yeah,
was going there. Let's
I like it.
let's go
I
back.
like
Let's go
it.
back.
I like it. No, and you're right. Yeah, it is definitely in the eye of the beholder. So, interesting. So, all right. So back to the completions. There's more. Like I classified the different types of completions that we could have, and there's more than just what we had here. But like one of them is classification, where you can kind of sort things into different like predefined categories. And so one of them might be you had, let's say, tweets or something. Is this the sentiment of tweets would be one. So you can feed it into the prompt. This tweet has a positive sentiment. This one has negative. Where does this one fall? And it would tell you. Another one would be the generation. And this is one where a lot of people think about with like ChatGPT. I want to come up with the next great business idea for. Oh, how about this? I want to come up with the next great hack together idea so I can win the big prize in cloud native. What will it be? And then it generates an idea. And so you want to be real specific on your prompt that you give to it. Another version of the completion would be something like a customer service agent where you can go back and forth with it as well. And it kind of remembers what you said. And then finally, this is one I kind of like, the transformation, where I can say something to the model and it transforms it maybe into a different language or even maybe to emojis. So I can say, you know what, Diego, transform this movie title into emojis for me, and it does its best to transform it. So it kind of has it's it's cool. So it's not just transforming in one language to another, can do a bunch of different things. So yeah, so those are completions. You feed the model in with a prompt and it comes out with something.
Yeah.
All right, then tokens. Now, this tokens, you'll see I have a little token, a little coin on top. On all of these slides, Diego, I had emojis after all of them. And tokens, for whatever reason, was the only one that showed up with the application we are using to stream.
If the system had to pick one to keep, I think that going on with the token,
Yeah.
given the context, I think there's no way escaping the token problem, right?
Yeah.
We cannot hide that problem. We need to talk
No.
about it.
Yeah. That's a very good thing. A very good point. So what a token is, so we can think, let's just say we're feeding in a sentence, one sentence.
Mhm.
And then in that sentence, let's say we have 5 words. But we could have 7 tokens within those 5 words. And so a token really is like the smallest unit
Yeah.
that a model can understand. And it doesn't necessarily mean you don't have one token per word.
No.
So it's a little bit counterintuitive. In my head, I kind of keep it straight as one
We're
token
gonna.
per word, but that's just me. But
It makes mostly sense, or at least you can say that a token is the most common length word. So you might have the, most of the word we map to one token, but you can have the one is mapping into 2 because it sounds more like is longer than the average single word. One thing to make sure here, also, we're gonna see that later, right? There is no one token measure. You were talking about, is the smallest things that my model can understand, and you just anticipated that you've got at least 4 models type that you drop in there. So how big is a token, how many words, characters goes into that? It is really model dependent, so you cannot just go off and say I calculated the tokens and then might completely fail if you're trying to use that onto like an embedding model, because you needed to use a token calculation or whatever strategy that it is,
mhm,
model
that's
specific. Each
that's
model, they're gonna see that in Azure, like you said, second line, right? That's how you get billed. So that you want to you want to know how many tokens you are consuming. One thing also that to make into account, tokens here when you send the prompt, right? When you ask a question to a model, token is not just the limit it can understand, is the limit. So usually if you work out and use out all your token in the question, then the answer might come back empty or awkwardly cut. So really tokens, it's important. The token is the overall size of things going in and out of your GPT submission.
yeah.
So it's very crucial to treat them carefully, because doing that wrong, yeah, it costs you money, but also can give you back not the great answers just because there wasn't enough token left for the model. Says, hey, that's the cool answer you wanted for. It might come back empty.
Yeah, no, that's a really good point, because I think we all probably, if we've messed around with ChatGPT enough, we've all come around where it's just kind of stopped mid-sentence on us.
That's it.
And
That's a clear signal that you just reached that submission token limit. There wasn't enough to give you the rest.
yeah. And so, yeah, I mean, and now we've taken something that we've hit and now we know why.
Yeah,
And
nasty. And it's
yep.
not really clear. Why is that happening? Why is it this mid sentence?
Yeah.
I thought it was clever, right? It's
Yeah.
intelligence, generative AI. Why
Yep.
would you do that?
Right. Exactly. And you run out of tokens, and that's because the model is no more for me. So, and it's important to understand, because it is how you get billed at a practical level as well.
Yeah,
So,
that's the credit card moment is
yeah.
impacted by that.
So now let's go over to embedding. So there is an embedding model.
Hmm.
Um, and so what you can do is you can essentially throw in a prompt. The prompt gets broken into tokens. And now you take that token and you get a numerical representation of it,
Yep.
AKA a vector. Um, and then what you can do then with this vector is that now I don't know how the vector, is it like just a 2D vector, or is it more like than
Is
that?
a is a vector that contains 1536 floats.
All right.
So that's the size of the vector you get back from the model that we most commonly use, which
Okay.
we're gonna see that later. Is the ADA text generator. So it's a single dimension. Sorry, is a single row with 1536
Wow.
dimensions. It's
Wow.
huge.
Wow. Amazing. But what you can do with that, a vector is a vector when it comes down to math, and you can do some math then to identify linguistic problems. So,
Yes.
and that's pretty cool then. So you're taking language and reducing that, I say reducing probably in quotes, to a mathematical problem, which computers are good at. So, yeah. So that's what we're
Funny
embedding.
enough, they call them embeddings because it is a dimensional reduction. They get reduced down. And the other thing that is interesting is that they're numbers, right? We all know that if you got object and string, right, you can get hash code. That's going to give you a hash code. Is an int number that is somehow related to that text. Now in embeddings is beyond that. These awkward numbers are not just numbers. They represent the meaning of what that sentence is about, but they remove the language. So the beauty here is that the model will be able to build these vectors regardless I'm submitting something in English or Italian. That doesn't count. That thing would just be able to calculate because now it's moving from my language up to the semantic meaning. That's what they try to represent is a sequence of number where some number in that thing would mean dog, something would mean house.
And that's a really good point, is that it has that semantic meaning to it. And then you can do things like searching based off of it too, because the vector means something. And so you can do things like a cosine similarity. You can
Yeah.
do these mathematical functions and find like these vectors that are close to each other via the mathematical function, and then know that they linguistically mean something.
Yes.
So,
And that's compare again, we all use two other way to find uh, closest text. We know how, you see that every time you're typing is trying to suggest, your um, completion will suggest you the closest word to whatever you're typing. That
mhm.
is only based on how different two strings are. This one is how different are the things we're talking about. So if two things are talking about the same stuff, then the vectors would be very close to each other. And so
That's
that's where this technology you were talking about search, we're gonna see that you can do a lot with just embedding in terms of a lot of the application you mentioned before. I thought on your list you had things about classify and label.
mhm.
You'd be surprised how this is making a lot easier to have a very fast labeling things because now we're looking for similar concept
Similar. And that's cool.
in meaning.
Right. And that's cool. So, yeah, so that's why embeddings are really something to understand. So you can kind of at least understand how it works at
Yep.
an idea level. And so it makes more sense than when you put it into action. All right.
But
So,
that's the first time you're gonna see you run out of token. That's where it starts. That's the first time you get your unfortunately the issue with the token.
okay. All right. So Diego, let's take it away. Let's
Yeah,
start
so
seeing the
now
stuff
we're
in
in
code.
my domain. Welcome to Polygon Notebook. For whoever is familiar with this is the notebook UI of VS Code, and that looks similar to any other notebook. If anybody here has got any experience with Jupyter Notebook and the likes, difference is we can use more than one language. In this case, we're really just going to be working mostly with .NET. So that's C# that I'm using here. With this command, I just loaded the packages that I need. This is our OpenAI SDK. We're going to use that to connect. And also got a couple of utilities that guess what, they're providing all those tools for similarity measure and few other things. The first thing I would like to show, we were talking about completion. Let's try to use a GPT model. I already ran the first things, and now I'm going to get my configuration. So I have a deployment. This is what they're going to be able to do to right at the end of this once user are having access to the configuration. You're going to have my key, then the endpoint, And finally, I need to provide this model. Now, when you deploy in OpenAI, you're going to have a few different things that you label. In this case, I kept the name of my deployment the same as the model. So I'm using the GPT 3.5 16K. 16K is the number of token I can use.
Okay.
And that's important. GPT 3.5 before was, I think, 5,000 tokens. And in a long conversation, you hit that pretty fast.
Mm-hmm.
So I create a client now. You can see here down in the variable, it's showing you the values, of course. And we understand about secret, so you don't see the key anymore. But now look at this one. We're talking about submitting a prompt. In the GPT world, you're submitting chat completion, which is a chat conversation. So when you're trying to submit things to the GPT 3.5 or 4, if you got access to that, the thing is that you need to create these completion options. In this completion option, that's when we're using the deployment. So we're telling that we want to use this model. Temperature is how you want the answer to be, creative or not. 0 means stick to reality. Don't hallucinate beyond craziness. But this is how I submit the prompt. In this case, we're submitting a conversation. We're trying to see how this is going to be completing. And you see, we said we are defining a role system. This is a very specific message. You're going to see that later. You're giving a persona. So here you could describe, you are an assistant, just answer things professionally. So you're trying to set the mood. And if you want, you were talking about programming by prompt. You are configuring the model to behave in a specific way when answering back. So that's your first English statement-driven programming, natural language programming things, whatever we want to call it. But then there is a chat. So usually your prompt, you are the person. So the person say knock knock. The assistant, this is the model, has generated a response and says who's there. And then the user says orange. At this point, how do you complete this conversation? Orange who?
Nice. And so that's the one that came back from the model.
Yes. So he went through that conversation and he said, the next step in this conversation is the assistant is going to ask you back, orange who? That's because part of the training, I don't know how many knock knock jokes it must have gone through the training. I think quite a few. But now, also another thing is that you are familiar when you were running things where you saw the responses coming in one at a time. So you got two part of API. If you're trying to build if I were to build like a chatbot through, I don't know, a Teams bot SDK or things like that, probably I would like to keep this in a way that the user sees the stuff is going on. Because if you were dealing with a person, right, on the other side, we would stream. You're not waiting to write everything. So this is your chatting conversation. You could either go for the full response, orange woo, or you can see here that as soon as every part of that sentence were ready, those things were produced.
Oh, cool.
And this is the hello world. So at this point, we know how to deal with GPT models. This is same for 4 and 3.5. The most important thing is this. You are providing a list of messages. There is at least one that we are given. But how do I remember the conversation? Is that every time we get a response back, so the way these things would really work, this response that we got back here, this message, we put that back in. So now let's do a thingy.
All right.
I had this thing, right? We do the same job. The only thing is that the system replied back to us, orange who, right? So that is an assistant.
Okay.
Because that was the message that he sent us back. Orange who? At this point, we need another user message. That's the next question we were going to print out. What do you think I should put in here?
Orange who? I don't know. This one's tough. How about I should chat GPT it.
No,
I don't know.
wouldn't. That's
Yeah.
cheating. That's cheating.
Yeah, it's cheating. Orange who? Knock knock. Who's there? Orange. Orange who? Orange juice? I don't know.
And we
What's
run
gonna happen?
this.
Ah, is that funny? I don't know.
No, so that we can trick this as a you have assistant, and you do very naive dad jokes.
See, now that's awesome. So what you're doing right here is you're setting the mood. You're saying, you know what, this is going to be very funny. Why didn't I know that joke? You're setting the mood by saying bad jokes,
Yeah.
and then you're going through the whole thing. And what's neat about this is that you have to send that entire conversation back every single time. You
What
are
would that
not
happen
happy.
now? So there you go. So the system message, you see, is really driving. This is my configuration, right? Imagine you are setting all the parameters. That's the system message.
Mhm.
Then the user and assistant are what we go back and forth. Still though, you can still do things like this. This would be a very perfect, valid, non-conversation use of GPT. You can just go with this.
That's cool.
You see that?
Yeah.
So at this point, using the prompt, I'm not having a conversation. So at this point, if I'm not putting things back in that collection, GPT doesn't know.
Right.
That's the memory. The transcript is this.
Got yeah.
So whoever is
Okay.
building this and is thinking about making a chat agent, managing that, I usually call this, one of the terms that we use is that these two pair is what we call a turn. That is a turn in the conversation. You
Okay.
ask a question, assistant give you back. So
Okay.
you keep those two things together. So as soon as we put back this one, we have completed the turn. So we want to keep track of all of this because that's how we keep the context, right?
Mhm.
Well, this one is absolutely, if I now ask, so I said I want that. If I now ask, can you do better? There is no context. This is all gone, right?
Uh-huh.
Well, better about what, right? So
Right.
that's what the user needs to do. So here you can keep track. If we did that and we loaded the previous answer back in, we would have had our conversation about programming. To an
Right.
extent, that's how the Copilot chat works. Is a tune GPT model that knows about writing code more than answering any genetic question.
Cool. Gotcha. All right. So the like the Copilot, then its system message to be really kind of to dumb it down, so to speak. Its system message is more like you are a helpful assistant that's really smart about writing code.
It's something like that. And then
Yeah.
also the model has been trained onto answering question about code.
Okay.
So this is what people call a tuning.
Gotcha.
While
Okay.
this is GPT is trained on a corpus of a gigantic amount of tests. You can answer a lot of things, but be careful, is gonna, oh, that's the problem with this thingy, is always going to answer.
Okay. So no matter what you put in there, this model is going to come back with something.
Yeah, now this one it's easy, so I cannot, but it's very hard to understand when it starts. At some point, it's gonna start to hallucinate,
Yes.
and it's gonna happen in a very beautiful and elegant way. So watch out. But now back to embeddings, right? So because now we're gonna see something interesting. It doesn't know what I did this morning.
Mm-hmm.
So it's pretty simple. Here I could have saying, I could have had a message to say what I did this morning.
Uh-huh.
But how do I load that data? How do I find things that are relevant to the question? Because you don't want to flood. The more we put in, this list is going to grow and that token limit is going to hit us. That's where let's have a quick look about embedding.
Okay.
Now, embedding, very similar story. The only thing that is different now is we're going to use an embedding model. So let's connect. Oh, I didn't do this. Let's connect again my API key, which I'm going to change after this. Secret rotation. And then we're going to use this model. So I'm using an embedding model, not a GPT model. Same API as before, we're building the client. And now look at this. I have some text, so I'm building something silly. And then we're going to see it down here in the variables. I have this silly long text is an array. And now we're going to calculate our embeddings. This is what we get back.
Okay.
You see? Very interesting and insanely long an array of things. Is that useful?
Yeah.
Yes.
Yeah.
One thing I suggest people to do for performance and speed, because this is only 4 things, it's okay. But in .NET on Link, we got this beautiful thing, the chunk. So this is gonna slice my collection into blocks of more than 1 sentence. So we're gonna make 1 request, and each of them will contain 4 elements. This usually is a strong advice when we're talking back about the. This is more about the speed of things coming back. Embedding is not gonna be fast.
Oh, I love that.
That's the problem now. Let's go with this. I'm loading the packages. The beauty of these commands will provide, all these packages are on NuGet.org. You see that some of them is a pre-release, but they are publicly available. So there is no special Microsoft sauce that we need to do to get access to these utilities. Same job as before, but now, so we've seen embedding was working. But what happens when I build a very, 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 very long text, which is very silly? AGI, 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 AGI. Unfortunately, this is what's going to happen.
All right. It's saying that you've
nice, right?
Yeah. Maximum content length is only 8191.
But I put in 10,000.
Yeah.
So, hello, welcome to the real world. This is the was that the red pill or the blue pill? So, but we can help you. So in the utility package, which I really suggest you use, is this one up here. We have few utilities. The one that I really love and I cannot live without is these tokenizer things. So I'm building a tokenizer object, but I'm building using ADA2. It's the same model that I'm using for the embedding.
Okay.
As too much. So now I have this new utility here that says cut it down. So I'm now slicing that text by token count. And you can see awkwardly that the 10,000 token was this many characters. So that's the string length originally. Once I tell it to be behind, under the limit of the token, that's how long is that string.
Interesting.
Now at this point, right, I can chunk it, but this time I do something more interesting because here I truncated. I lost. The difference between these two texts is lost, is gone.
Okay.
And what if that was useful? I mean, this could be a very interesting paragraph with data. So we don't do that. Truncation is like, this is the example, but that's not what you do. You don't cut down things. You slice, you chunk, I don't know what we want to call it. But you want to cut things in bits, but you want to send the whole stuff. You want to retain everything. So this is the next thing that we want, is chunk by token count. So now what this thing is doing is taking my long text, and instead of one string, it's going to give me a bunch of them. In this case, you're going to see is 5. Each of those contains 2,000 tokens max. And now we can finally do the embedding. We embedded the entire long text, but it's made of slices.
Okay.
And with these two concepts, I think we're almost good to go and start to understand, what do I do with that? Oh, one thing that you can do is that we can search. You were talking about search.
Yeah.
Let's see if this sample is good enough. Again, we're going to get a few things. Now, in this sample, we're not going to do anything clever yet with ChatGPT or the likes. So we just need to be able to calculate some embedding. And this is the, if we're talking like, very sophisticated, I mean, cognitive search and those things are more sophisticated than this notebook. Otherwise, you could just use this notebook for free. You didn't need Azure at that point. But this is a toy example to show what it means to build a semantic search. We build a client, we've done that. Now, I have run before another notebook. Also, all these cookbooks are available in the Azure OpenAI samples. So everybody can access this anytime. But I'm going to try to load back a JSON file where I've gone through 1,000 elements with long text and build the embeddings. So I created my data sample. And here we can look at. These are only the first two. You see that I've got a summary, a text. Out of this big text, I know it's 34 tokens, and these are the embeddings of whatever text is in here.
Okay.
Now, what we're going to do is that we're going to create a function. And this function does something not too complicated. We have loaded, so we have a collection of this data raw, which is going to be our data. Then we have a question. This is our query. And this is just a way to limit, you want to have some number of responses. How do we use embedding? So if we go off, and this part is about taking our question and getting us back the embedding vector of this query. Right?
All right. Okay.
Then on this data, we have a field, which is the embedding property on the data raw. So at this point, we're using a cosine similarity. So that's how we're going to measure distance. In cosine similarity, if two things are the same, it's going to give you back a 1. If they're absolutely unrelated, it starts going into 0. So think of that. It's called cosine similarities to an extent. Think of that like two vectors together. And then if they're similar, they are the same things. If they're not, they start creating an angle. Right?
Okay.
So we are measuring how divergent the meaning of things are.
Okay.
So now we're using link. So this is all in memory. We have a collection. We score every single element in data against the query embedding. So now we're going to then order them so that the highest rank are at the top, and we take whatever count we need.
Okay.
Essentially, we are searching for the 5 most relevant things for the question we have. So now that thing is a document that contains reviews about food. That's also why the name Find Food Reviews with Embeddings. So that's what that data is about. So let's find out. I want 3 responses related to whole wheat pasta. We run this, and there you go.
Cool.
So we just implement a semantic search.
Nice. That's awesome.
And
Go
no
ahead.
GPT models were harmed in doing this. And this is just embedding, just to show you the power of, being able to measure how things are close to each other. And then again, there's more questions. So there's not really too much exciting about it, but that's what this does.
Well, I'd argue with you that there is a whole lot exciting about it. The code, maybe, the code's straightforward, but there's a whole
you're right. But let's talk about something else. You were mentioning about labeling things. So now if I can find things that are close to each other, so we're gonna do, this is product reviews again. We're gonna go with the same data, but let's look at this. At this point, I have this function. What this function is actually going to do is that I want to go through. We know that in this data, there is a score field. Now, what we do is this. We take all the embeddings of everything that is greater or equal than 4. Those are positive reviews. Everything below is negative.
Okay.
One of the things that you can do with vector and with points, you can calculate a centroid. Centroid is pretty much the average or the center. If you were to draw all these things on, if you were lucky enough to have just a 2-dimension instead of 1536, that would make it so easier to see. But at this point, it's giving you, given all these negative reviews, what is the middle of this cluster? And the other one is getting the middle of the average good review.
Okay.
That's what these two things do.
Okay.
And then what we do is that using the same job we did before, we now score each review item using their embedding. And then using the similarity, we apply the label. So this is the scored label.
All right.
And we're using these centroids because at this point, for each things, we are keeping our predictions. And this one is beautiful because we already calculated everything. So I don't need to invoke any model. And you can see here, 5, I applied by hand. So this one that you can see at the label is something that I apply using the same rule. I know that if it's less than 4 is negative label, more than 4 is positive. So these are the strings that I'm using. But this one here is using, given the labels here, and given the review embedding, is getting the most relevant label out of that.
Okay.
So if it's negative, negative will rank higher. If it's positive, but that's only based on the embedding. And you can see here that so this probability is how confident. So this is the distance.
Right.
So at this point, from that centroid, that center of things, we know that this was an 87% confident that this review was a positive, but that wasn't done using this. This was done using the embedding part of this text.
Of the text. Okay.
Yeah. So now you're using that to classify.
Cool.
And that's where things becomes very powerful. Because at this point, you're able to see that this would be the place where you would have run. I mean, it would be more accurate if you were to train a model. So you're going, down the machine learning path. But this has been done by calling a model, getting our embedding in order, and then through, let's say, old school math, as you said before, we have been labeling things. I imagine you have got more things. This becomes very interesting to summarize things and stuff like that.
Yeah.
And then brings to the real thing. What do I do with embedding? What do I do with chat? When do they come together?
Okay.
Is question answering.
Yeah, nice.
We got that, right? So what we're going to see here is that we are using the things that we've seen before. So no surprise on the packages. But now we need to use everything. We're going to use both ChatGPT and our embedding model and the data to be able to answer questions that GPT doesn't know about. But we have data to use.
Okay.
So again, we're going to need my key. He's asking me for the endpoint, which is this. I want the deployment of my embedding, which is the ADA. And then we need also a GPT model. Cool. So far, we've seen this so many times. I think it's a no surprise for the people at home. It's all safe. You can run it. But now look at this. We're going to ask a question about Winter Olympics. So this is the system things that we've seen. And this is my question.
Okay.
If we run this, we've seen that before, right? Doesn't
Yeah.
matter.
Yeah.
Cool. Let's do something clever. Now I am loading. I copy pasted this from a Wikipedia page.
Okay.
And it's you trust me when I say it is something that's got to do with Winter Olympics. Now we're going to do something slightly different. We are modifying the template. You see now my question, this is the prompt template part that comes into place. I'm telling something different. Use the following article on the 2022 Winter Olympics to answer the question. If you don't know, answer I don't know. This part will be replaced with a text.
Uh-huh.
And this one is my question as before. We run this. Oops. And we just need to do this. Because of changes. Welcome to live demos. Chat deployment. Now GPT knows.
Nice.
So we provided information that was coming from some, knowledge base. In this case, I just copy pasted.
Right. And so you can ask it free form questions.
Yeah.
Give it you're essentially, yeah, you give it the content and you're asking free form questions off that content essentially. Correct. And you can imagine the applications, like if you had at your, like a healthcare plan.
Yes.
And you can question that healthcare plan, like, do I have, vision? Can I get prescription glasses? Are those covered? And you don't have to dig through.
Very important. You're making a very good point, because it's not a healthcare plan. It's your healthcare plan, right?
Exactly.
So do we want GPT and OpenAI to have access to my policy so they can train GPT for everybody to ask about my policy? I don't think so.
No.
So this thing is called RAG, is Retrieval Augmented Generation. So we retrieve content, which is the article. We augment our prompt so we can consume it in our question, and we generate the answer. So it's a very important pattern in generative AI. RAG is where you bring your own data. And you're going to see lots of sample online about bringing your own data.
Yeah, that's cool.
So at this point, I don't want to annoy much, because we've done this before, right? Now I have run code that scan Wikipedia on specific categories that I wanted. For all of these pages, I've been doing, guess what? Chunking, because they were big. So I had to slice them up, calculate embedding, and I save them to disk. You can see that I have this page block, because one page is too big for our query. Also remember, even if I got the query, right, I put it inside here. Now I have the other problem. I also have got the token limit on the GPT to take into account. So the embedding only is not enough. There is more text, plus the system, plus the answer that we want back. So really careful now. That's why I have slice. Also because in a page, usually in Wikipedia, it covers a lot of things.
Right.
Now, what this system is going to do is just going to load the data. And now we build a smarter search. Now, this search is going to use our query, the knowledge we loaded, same things that you've seen before, right? Now I can search. Correct? So let's make our ask function.
Okay.
Guess what? tokenizer, GPT 3.5. Now we need to accomplish the same job, but I do something different. Now we ask, so we search, given the question that we want to have an answer for,
Uh-huh.
we find if we got any very relevant documents to use, we put them here, and then we go with the prompt that we all know. So this is the same as before,
Okay.
but the question is now augmented by searching the data that we want. So now
Okay.
embedding and chat will be working together, and now knows how to answer.
Cool.
And this is how pretty much all the things that we were talking before, we're bringing them in together. So this is how these things are now able to, I can process data. I can bring my own data into the game. Now we can query that, find slices, and then augment our prompts. And then now GPT knows how to answer. Thing that is here is that this is not a chat, right? Because now we're just using this as a single shot.
Right.
So we're not keeping track. So this is not a conversation about sport. I just built a sport completion.
Okay. Cool.
That's, to an extent, this is all there is.
Easy.
Yeah. What can go wrong with that? I don't know. Lots of stuff. Because this is the trick. How you ask this question, how you cleaned up the article, the example. There is a lot you were talking about. I mean, you've seen the one before. We were doing the conversation about the knock knock joke, right?
Mhm.
The prompts, the history, and the system message, they do create a gigantic difference. They drive how the model will produce generate the outcome.
Mhm.
That's where the fine tuning, the tweaking art come into place, and that's where application becomes smarter than other. At the end, most of us are going to use GPT models. So if something is better than something else, is in the quality of data.
Mhm.
Now, we just went through slicing things that we know. But remember that you can create a prompt to summarize things. So I challenge people to do something clever. Like imagine you go through, I don't know, we got a transcript from a conversation, right?
Mhm. Mhm.
That's long. We
Yeah.
could think of not slicing by token, but slicing by time,
Oh, nice.
right? But then you can say something like, hey, given these 4 minutes conversation, what are the main points that the speakers are trying to do? Now we can use GPT to create a summary, a compression, whatever we want to call it, of that piece of text. And now we build the embedding of that one. So now we have a summary of that 4 minutes conversation. So we don't need to load 3 hours meeting
Nice.
in our bot. So that's where I challenge people. This is where things becomes really cool when you mix them up.
Yeah.
GPT to generate knowledge, to embed, to create knowledge store that you can retrieve, to ask question and improve. Those are all things. And you can see that also. I don't think we got enough time to run the this one only because Whisper takes a little bit of time. You are uploading a file pretty much, and user can use this one. It's pretty simple. But one thing to take into account is that the prompts, you can see here that by providing prompts is then modifying text.
Cool.
So that is how you make the translation better. But usually people will do a job where things let me see if I can find it. So transcribe is just going off and calling the whisper model. But then here's what they do. You could mix and match.
Mhm.
At this point we have this is using GPT to create a good prompt.
Hmm.
So you can see here that I'm asking, and look at the person. You are a transcript generator. So we're going back to the configuration, right?
Right.
You're tasked to create one long paragraph of a fictional conversation and is telling what this should be about. Now this is what it creates. And then I use this prompt from GPT into my Whisper model
Okay.
to improve.
Cool.
Change the accent. Here you can see that this is the prompt they put in. It's always the same. In this case, we're using the same file as a audio file to transcript. And here's what we got the first time.
Uh-huh.
And here you can see that, I mean, you will need to read it, but there are a few places here where the tone of that transcript is different. And that's because this was the prompt. And now we're mixing GPT and
Right.
Whisper.
That's cool.
Now it's GPT driving Whisper. That also are the neat things to do where then you use GPT to embellish Whisper. Here, for example, we use then GPT to rewrite and fix the transcriptions.
Nice.
Putting
Yeah.
back, the right. This is you are. This is also doing a very interesting things where the transcript originally, those are people talking. Unfortunately, like us, we got all these acronyms. Do you see this one?
Mm-hmm.
I have no clue what that is.
Mm-hmm.
There's other stuff like that. So now at this point, though, GPT is telling what to do given this transcript.
Okay.
And you can see here that it's doing the things that acronym
Nice.
has been expanded. You can see this?
Yep. Earnings before interest, taxes, depreciation, and amortization. Nice. Well, that's really
Here
cool.
down too. So that's very useful. Mixing these two things, the generative text and other model, now you're getting your assistant. But you see this one is not a transcript expert, it's not a transcript generator, it's an assistant that specializes on financial product. And here you can see that this call is about the earnings call. And then you can see here that you should rewrite acronyms this way.
Mm.
And that's what this thing did.
That's what it
This
does.
acronym has been expanded in that pattern, while here it wasn't. And this is just coming off straight of the call. So here you can see this is the audio transcript.
That's really cool. That's really cool.
Yeah.
All right. So I know we're a little bit over in time. So if we can bring
classic Diego meeting.
Yeah. So we bring us both on screen.
Oh.
So what I wanted to do real quick is there we go. So I wanted to talk about the OpenAI proxy. So Diego, first off, what we're going to do is we're going to take the Polyglot notebooks example that you were showing, and I'll put the link for it in the show notes for this stream so people can go and just directly link to it and check it out for themselves. And what you all could do with it then is check out the OpenAI proxy. So we don't have all the models in this proxy, so Whisper is not a part of it, but the GPT models are in there. I believe Ada is in there for embeddings, but I wanted to show everybody how to get access to this. And so let me share my screen, present. Let's see, share screen, window.
I think also they're going to have access to DALL-E if they wanted. Is that in the
I think so.
proxy? There is a sample that they can go. That's the shortest sample. For some silly reason, I skipped it. But that was the quick one to grasp. But you can see how that thing is using the prompt and tweaking the prompt. We give you better images. Pretty neat.
Cool. All right. So we should be seeing my screen right now. So if you go out to the, when we go back to the slides, there's a registration address that you go to. Go to that address. It'll be brought to you to a Microsoft form. You fill out the form. It's pretty much giving us your name, email, and your GitHub username. You'll get an email then with a API key. if you go to AOAI, Azure OpenAI.hacktogether.net, that'll bring you to this chat playground. And so this is just a cool thing that you can go through and kind of, as we were showing before, like play with the system message and then start chatting. So you can kind of play around and when you're prototyping your app. So I'm going to enter my API key here, and you have to do / in your GitHub handle. So just FYI, that's what we're looking at. Oops, authorize. You can see now I'm hacked together by name. And so now I can do you're an assistant. It helps people find info. And then I'll just say, was this the best stream ever? Send it. And it's probably going to tell me it doesn't know what I'm talking about. Yep. So, but anyways, you can go through and you can change how many tokens you can go through. We're limiting it only to 2048, a little bit less, but you know, that's what it is.
That's good enough.
Yep, it's good enough. And you go through for Dolly here. Let's see, cute picture of a black long haired fuzzy cat, because that's what I have.
With bananas?
With bananas. Let's see. Come on. Takes a while. And there he is. That looks just like my little guy. Half on screen. He'll never look at you. All right. So that's what it is. And then when you actually need to use it, this was also the endpoint that you're going to point at.
Oh, lovely. So that's the endpoint.
Yep.
Do they know what's the name of because the API will ask them to provide the deployment name?
Yes. And that we have in our documentation for it, which is linked in the email, and we list out what the deployment name for it is, which I believe is the same. I think it's just GPT 3.5. Let's see, aka.ms /hacktogether/.net. And let's see, OpenAI README. And if it isn't in here, I will put it together.
Oh, there you go.
Okay.
Perfect.
All right.
One suggestion: don't play too much with the DaVinci.
Okay. Don't play too much with this one. So pretty much chat completions and embeddings is what you want to use.
Yeah,
and I'll put sorry, go ahead.
Completion pretty much is what we did, but not providing history. We were using chat GPT to do text completion. Generally speaking, OpenAI and including Azure OpenAI, we are moving. So that, these things has been around for a while now. I know that people are getting their hands on just now, but these things has been in development a little bit longer.
Okay.
And so the way to do things at this point is that GPT models are cheaper than they used to be. And so chat completions and embeddings model, those are the way forward. The text completion, like DaVinci, were at the beginning of this. They are incredibly good, but as a transferable skill, if you want to use that term,
sure, that's
the type of LLM interaction, if you want, that is phasing out in favor of, we're getting off with GPT-4, and then it's going to be GPT-4V. That's where the world is going. More GPT kind of models and less of DaVinci. So they can use anything here, but
gotcha.
GPT is the beast.
All right. So that's what we'll put on there. And then we also have Dolly, and I have to update the README to include what the Dolly model name.
And then they can use the number of tokens, right, in the tokenizer, as we were showing the sample, so they can preemptively do things with the text.
Yep. And we do show like the number of tokens. Let's see.
It's up there. It's on top right.
Yep. So we say you're using 124, and I can do start chatting, and I'll say hello there. Send it. And you can see right down here, you can see that used 24 prompt tokens and then 33 total tokens.
Because if you ask now another sentence, even if you ask the same question, right, you're going to see still is the prompt is still going to be 24, but now we're going to go up because it's keeping track of the history.
Yeah. So I'll just do hello there again. Oh. So
that's, you see the 52 below, that's the one to keep an eye on.
yep. Yeah, your total. Cool.
Because it's 43 of prompt, that's the whole history, and 9 of response.
Yep. And so
That's the completion tokens, is how much tokens were used in the response only.
yep. And then 66 on the prompt, and then 284 overall.
Total. Yes, if you add them together, the prompt token and the completion token count, that's giving you the total number used. That total has to stay below 1024 in this case for the settings that are in this.
Yep. And
which
so
I think for the app, that's for an hackathon and testing things out, it's fine. Real world scenario, we need to get clever.
Yeah. So cool. All right, I'm going to switch back to, or shut off my, let's go. Perfect. All right. Here we go. AKA ms/hacktogether/.net/Azure OpenAI access. So limited access, 2048 most per session, and try not to abuse it. We are keeping track of who's doing what, so we do know. But
we know what you do.
Yeah, we know the tokens. We don't know what you're passing it. So,
oh yes, no, sorry. Yeah.
But
sorry
we do
for
see
the ominous joke. Yeah, we don't know what you're submitting, but we know how much tokens have been used.
Yeah,
That
we
one
do.
we know.
Yeah, we do know a token count for this, but we don't know what you're submitting. We don't see that.
Absolutely.
So, and then the proxy instructions with the README page that I just showed is off that bottom link. So, yeah, there you have it. Diego, thank you very much. I thought this was a great session. I learned a ton.
Thank you.
Yeah, this was wonderful.
I enjoyed it.
So yeah, me too. All right. So I know we took folks a little bit over, but I think it was totally worth it. And so don't forget, get everybody's Hack Together sessions together, your entries together for the Great .NET 8 hack. You have until December 4th to get everything in. So go to that URL and get things in and ask questions. Ask questions on the discussion forums. We're here to answer. So great.
Yes, please do.
Okay. Well, thanks, Diego. Thank you, everybody, for tuning in. Bye-bye.
Bye.